Welcome you all in the session 3 of day 3. So today we have Professor Dr. UK Khare, who is HOD of GC Modasa also. So he will be delivering the lecture on the ozonation in wastewater treatment. Dr. Khare is presently working, as I told you, as a professor and head of civil engineering department in this college. He has obtained his PhD degree from IIT Kanpur. He has more than 25 years of teaching experience. His area of interest is advanced oxidation process for wastewater treatment. He has published 5 papers in various journals of international repute. In addition, many papers in the international conferences. He is currently guiding 3 PhD students and many tech students. He is the DPC members for many PhD students for different universities. So I once again welcome Professor Khare for giving the lecture on ozonation in wastewater. Thank you.
Thank you, Dr. Singh. Am I audible?
Yes, you are audible.
And I have shared my PPT. Is it visible?
Yes, it is visible. It is visible.
Okay. So, good afternoon, everyone. Welcome to the today's last session. I am going to deliver on ozonation in wastewater treatment. Particularly, I will consider the wastewater as a dye wastewater. As we know that in textile processing, dyeing is the main process in which large quantity of the coloring wastewater is generated, and it is, if untreated, discharged or disposed directly to the water body or disposed in any other way, it is going to create a problem. So treatment of particularly dye wastewater, I will discuss in coming 1.5 hours. The contents which I will cover during this presentation: introduction and characteristics of textile wastewater, treatment options for textile wastewater, ozonation of dye wastewater with actual experimental data, ozonation byproducts, which will include end products as well as intermediate products formed during the ozonation, and then discussion on some experimental results of ozonation followed by aerobic biodegradation. And if time permits, we will go for some study about mixed dye wastewater also, how the separation of the different dyes from the mixed dyes can be done using HPTLC. That will be covered. So, as far as textile processing is concerned, different processes are there, like sizing, desizing, discovering, bleaching process, mercerizing, dyeing process, and then after finishing, final product of textile is generated. So almost all, you can say all these processes generates the wastewater. The characteristics of that wastewater may be different for different processes. So two options are there as far as treatment of textile wastewater is concerned. Sometimes some industries, what they do, they segregate the wastewater, and after segregation, they are doing the treatment. And sometimes all the unit wastewater is collected equalized and neutralized, and then it goes to the further treatment. So different processes are there, different characteristics of those processes are there. So equalization is required to make stable characteristics, and maybe different pH strings from different sections. So neutralization basically is provided. After that, the required treatment is being given. So we will see first what is the sizing. Sizing is basically a process in which we are applying some chemicals, size material, onto the fiber, so as to give fiber some strength, and that is basically done before spinning or weaving action of the fiber. So before going for the weaving action and spinning action, we required to increase strength of the fiber in order to minimize the breaking of the fibers, and that process is called as sizing process. So in sizing process, chemicals mostly used, maybe mostly starch is used or starch derivatives are used. Some other binding materials, softeners, or some antiseptic agents can also be used, depend on the different requirement of different types of the fibers. Basically, the wastewater generated from this unit is high in COD and BOD, as well as suspended material, because size material are being used and they are coming in the wastewater also. T-sizing process is another process which is in which you are removing the size material which you have used. So as I told you that sizing is basically done in order to take or in order to give some strength to the fiber, and after knitting or weaving, then before going for the next unit, suppose dyeing, right? Desizing is necessary. Desizing means you are removing the size material on the from the surface of the fiber. So size must be removed before further processing of the fabric, as it can act as a barrier to the dyes. You are going to apply some dye to give the color to the fabric. So that will not be fixed properly if it is size before, because size material will act as a barrier to the fixation of the dyes. So depending upon the used size, alkalis, acid, enzymes, surfactant, different type of material chemicals are used for desizing, and the basic characteristics of the wastewater coming out from that is also almost same, that COD, BOD is high, and suspended solid material is also high. Next process is covering process. As the name suggests, is covering means again you are removing something from the fiber, but that is not size. That is basically the fiber, maybe natural fiber or synthetic fiber, as we know. So they may contain different types of the impurities whenever they are collected, either in natural process or synthetically generated fibers. So those impurities which can interfere with the dyeing and finishing, so they should be removed. Particularly as far as natural fibers are concerned, there may be natural oils, fats, waxes, some minerals, plant material. As we know that most of the fibers are coming from the plants, so some plant material may be there. Those substances present in the natural fibers. Whereas synthetic fibers may contain some spin fleeces material, emitting oils used during the synthesis of fibers. So it can be done either with water or with some solvents. Some scoring chemicals are used to remove them, those natural impurities or synthetic impurities from the fiber. Next processing is bleaching, in which natural color of the fiber is removed because after weaving finishing, you require to color the textile material. So in order to impart proper color, proper efficiency of coloring, natural color of the fibers need to be removed, and for that bleaching is done. And in that process, different chemicals used are sodium hypochlorite, hydrogen peroxide, as we know that leads toward basically oxidizing agents, so which remove the natural color from the pipe. And maybe optical brightness will also be used. So BOD levels of the wastewater low, but solid content can be high in this because we are using some chemicals, oxidizing agents. Next process is mercerizing process. In this process, basically this imparts or this improves the strength, luster, and dye affinity of the cotton. So for that purpose, some adhesives are used which are giving the lustering effect, means improving the brightness or looking of the fiber, and will improve some strength of that, give the dye affinity, improves the dye affinity towards the fabric. So cold sodium hydroxide solution is mostly applied for that purpose. This not only improves its luster but also make it to swell and adopt a proper shape, circular shape of section. Wastewater generated from the mercerizing is usually low in BOD and solids. Next important process is dyeing, and which is basically large quantity of the wastewater is generated from this process. Quite a large amount of dyes leave the process in an unfixed state. Actually, whatever the dose of the dyes which we are applying, or dyeing the fabric, or dyeing the textile material, 100% efficiency is never there. So unfixed dyes will be there. 40%, 50%. Generally, dye affinity is not so high. It is 40 to 60% only. So large amount of the dyes leaves the process unfixed, and that becomes a part of the dyeing water, which is to be sad. So typical pollutant generated in this dyeing step, basically color of particular that dye, which is used for dyeing the fabric, and some other different auxiliary adhesives or fixing agents which we are using along with the dyeing process. As I told you, generally 40 to 90% of the dye is fixed to the fabric during the dyeing. 40 to 60% is average value, almost that is more than 60% are given. Printing is the another process in which colored wastewater is generated, but in this section, quantity of the waste generated is somewhat less, as printing is the paste which consists basically water, thickeners, and some other elements, and that has been applied on the fabric to give the different pattern. So the waste which is generated from this is of high concentration compared to the dyeing process, but low in concentration. Less amount is generated as far as volume is concerned, volume is concerned. Then after finishing is done, after all these processes, material is finished, product is finished, and if it is mechanical process of finishing, almost no waste is generated. Finally, the rinsing is being done, means washed, final product is washed, and that also wastewater is generated, which may be of not very high concentration, but quantity is more, volume is more. So typical characteristics of the textile wastewaters are characterized by strong color, low BOD, as we know that most of the dyes are not easily biodegradable, they are type of material, hardly biodegradable material. So the BOD is low, unstable pH becomes the different types of the dye wastewater. COD is high, suspended solid is also high, and they have some presence of heavy metals in the depending upon the purity or impurity of the dyes. Approximate range, pH may be from 4.8 to 9.5, which is slightly acidic to slightly basic. COD may be around 700 to 3500, and in some cases it may go beyond the 10,000 also, depends upon the concentration. BOD is somewhat less, 200 to 1500. Total solids is also more, 2000 to 3000. Main characteristics of the external wastewater is what? BOD-COD ratio is very less, and that is the matter of concern as far as treatment is concerned. So, if you want to use the biological treatment methods, in that case, you need to improve the biodegradability of the wastewater, means BOD to COD ratio should be improved, which is very near to zero in this data. So now we see about dyes. Basically, dye contains two things. One is chromophore, which is responsible for giving the color to the dye. So it is a double bond, maybe CC double bond, CN double bond, CO double bond, N to N, which is called as azo bond. That bond is there. So they have conjugated double bonds responsible for the color and called as chromophores. So basically chromophores are causing the color attached with the some aromatic rings. Second thing is oxochromes, which may be ammonia group, carboxyl group, sulfonic groups, hydroxide, OH group, which intensify the color of the chromophore. So basically, I will show you in the next slide the typical formula of different dyes. Each dye has different chemical formula as well as different CI number by which that dye is being recognized. As far as azo dyes are concerned, so it is the abundant category among the different dyes which are used for textile processing. Maybe synthetic colored organic compounds, basically characterized by N double bond N, means azo bond. So this is called as azo bond. Basically, azo dyes are name is from that only. N double bond N bond is there, which is causing the color. So typical structure may be like this, called an azo group, which are bound to benzene or naphthalene rings are there, connected by azo bond. More than 50% of the commercial dyes are used basically of azo dyes as far as textile industries are concerned. More than 3,000 azo dyes are used currently worldwide for different purposes: textile, leather, printing, paper, food industries, and other. Basically, dyes are classified as acid dyes, basic dyes, reactive dyes, direct dyes, viscose dyes, wet dyes. All these type of the dyes are used for different fabrics. As far as acid dyes are concerned, they are basically water-soluble type of the dyes, anionic dyes, and which are commonly applied to the nylon, wool, silk, modified acrylics. And basic dyes have positive charge, ketonic type of the dyes are there, and they are used for bacteriology also. Mostly used dyes are reactive dyes as far as textile industries are concerned. They form the covalent bond, and that's why their fixing is very good with fibers, and they have low degree of fixation because of efficiency around 40 to 50% only. The covalent bond which they form, they took the lot of constraints, control parameters are there, and due to that, the efficiency of the fixation is somewhat less, but bonding is very good. So they are used to dye cellulose fibers, woolen, nylon type of the fibers. Another type is direct dyes, which are basically used for the cotton fibers. Its affinity is very high as far as cellulose fibers are concerned, and they are bound with the hydrogen atoms, and that's why they are fused very easily. As I told you, that reactive dyes bonding is covalent, and here bonding is hydrogen, which is formed very easily. Van der Waals forces and hydrogen bonds. Disposed type of the dyes are basically less soluble dyes, which are disposed in, dyes are in suspension in the water, and that's basically used for dyeing polyester yarn. Now, different treatment options for the textile wastewater. As far as options for the treatment of textile wastewater is concerned, there may be physical and chemical methods, which are well-known methods, conventional methods. You might be knowing also coagulation and flocculation method, adsorption method, in which some adsorbents are used, and dye is absorbed on the surface of the surface member. Basically, in coagulation and flocculation, we are applying some coagulants, and you are removing the dyes by forming the flocks. And in adsorption, surface phenomena, you are utilizing some adsorbent like activated carbon and some low adsorbents also. Locally available low adsorbents are also used, particularly in case of the dye. So they can be used to absorb the dye. Membrane techniques, in which different types of the membranes are used to remove the dye material, and then mostly used method, advanced oxidation processes, AOPs, that is used. Biological methods, as far as biological method is concerned, as I told you that dye wastewater or textile wastewater as a whole, they have very low biodegradability, and that's why, because of the low biodegradability of the material or wastewater, it is very difficult to use the biological methods, aerobic or anaerobic process. But sometimes some dyes, as I told you, have average or but not so low biodegradability. In that case, these processes may be used, or otherwise some pre-treatment is required, and then after biological methods are used. So in biological method, different processes as written here: ASP, touching filter, RBC, elevated rubber forms. In anaerobic, maybe anaerobic filters, USB technology, not directly, and maybe wet reactor, hybrid processes, hybrid reactors may be used. And then last one is combined processes, which is now mostly preferred process. Combined processes are mostly preferred processes as far as treatment is concerned. Anaerobic followed by aerobic processes, and maybe oxidative process like AOPs followed by biological treatment. It's the comparison of some advantages and disadvantages, which I think you might be knowing also, that coagulation process, flocculation process, economically feasible process. For the disposed type of dyes, as I told you, the disposed dyes is less soluble dyes. So you see, it is in suspension in the water. So coagulation, flocculation process can be applied in such dyes, but problem is of high sludge production and poor results, particularly in case of the soluble type of dyes like acidic reactive dyes. Activated carbon means adsorption processes, removal of wide variety of dyes. Maybe they are using this, but basic problem is of regeneration of adsorbent, as well as disposal problem is there, and that's why it makes it expensive. Phantom resin, which is also used at a good percentage level. Basically, as in previous lectures also, you might be given the information about the different other processes in which I think it could have been covered phantom reagent, basically H2O2 and iron acetate. Combination of that is basically phantom reagent. Its effective utilization for soluble as well as insoluble dyes. Good COD removal is also there. The only problem is of sludge generation will be there, and poor flux formation for soluble dyes. As we know that each and every process has some advantages and disadvantages. Ozonation is the next process in which it's the pure process, advanced oxidation process, in which ozone is applied in gaseous form. It's a very rapid process. It gives the color removal very rapidly compared to the other phantom reagent or others. So no sludge production is there. It's the very advantageous thing of this. Sludge production is not there. Increase in biodegradability is another advantage of ozonation, and that's why I told you that in previous slide also that sometimes combined process, ozonation or oxidation process followed by biodegradability or biological process. That is being done because ozonation improves the biodegradability of the wastewater. So that is the advantage of this, and disadvantage short half-life time is easily, and cost is very high. Another, you can say that it is to be generated on field, immediately it is to be generated. So you require to have a ozone generator like that. Membrane technique, in which removal of all types of dye is there, recovery can be done, recycling is possible, but concentrated sludge clogging and high cost is there because of frequent change of membrane. And then biological processes which are not directly used but may be used after pre-treatment, and that's why they are not directly used, but if we are using those processes directly, it took a very long time, because whenever the process is concerned, it took a very long time to have the result. Now, ozonation of dye wastewater. As far as ozonation of wastewater is concerned, we know that there are different potential of different oxidizing agents. As far as ozone is concerned, it has very good oxidizing potential of around 2.07 compared to the oxygen, which has 1.23, as well as hydroxyl radical, which has more than this 2.28, and during ozonation also hydroxyl radicals are formed, as we know, in indirect process. So ozone as well as OS radicals in combination, both they are having very good oxidizing potential, and that's why they oxidize the organic matter, they reduce the COD and TOC very nicely along with the removal of the color. So it is only second and third number as far as potential is concerned after fluorine. So at acidic pH direct ozonation, there are two pathways. As you can see in the lower portion of the pathway is shown here. Ozone is there, direct oxidation pathways, and then indirect pathway in which ozone consumption, decomposition via OS radical is there. So direct oxidation means ozone is directly oxidizing the organic material or removing the color. And second thing is indirect path in which ozone decomposition is there, causing the generation of OS radicals. Basically, as we know that for generation of OS radicals, some initiators are required, particularly here in this case. Initiator may be OH ions are the initiator, and then further formation of the, once the degradation of substrate occurs due to the direct oxidation of the ozone, there are formation of some aldehyde acids and aldehydes, and those acids will act as a promoter for the OH ions, for And then lastly, as you can see that indirect oxidation of substrate by OS radical is also formed by byproduct. And I will show you in the last section what are the different byproducts formed during the intermediate process of rejuvenation as well as end of the process. Radical consumption is also there. As OS radicals form, they are very unstable. As far as stability is concerned, OS radicals are quite high unstable type of the radicals. They generate and disappears immediately. Less than 1 second, within less than 1 second, you can see. So immediately they generate, they oxidize the metal and consume it. Again they generate and consume. So their half-lifetime is very less. So they are always very highly unstable type of the radicals. They are radical consumption is other thing is not there. In that case, inhibition also takes place because of the bicarbonate and carbonate. And that also causes formation of liquid. So two pathways are there. In acidic condition, basically when pH is acidic, direct resolution predominates. As far as alkaline condition is concerned, radical oxidation predominates. So ozone is very highly effective in neutralizing the ozone azure solution, being a strong oxidizing agent. Ozone is have very good affinity with the electron size. What are the electron size in dyes? Basically chromophoric azo bonds and double bond bonds and aromatic rings. So ozone attacks firstly on chromophoric azo bonds. Directly it attacks on chromophoric azo bonds, and then once it is being broken, azo bond is broken, this color is removed, and you can see that color is removed as bonds are broken. Then aromatic rings are being broken. After that, aromatic rings are being broken, and complex material, complex substances converted into single. So destruction of azo bonds in the dye molecules result dye degradation and consequent color removal, and aromatic rings destroyed then after basically form the aliphatic organic molecules as a byproduct. So as far as experimental study is concerned, 4 materials, dyes were used in experimental conditions as far as experiments are concerned. RB5, reactive black 5, reactive violet 5, 2 reactive dyes were used, purchased from the color chem limited Mumbai, India. The chemical formula you can see on the screen. Basically, reactive black 5, RB5, is divalent type of the azo dye. As we see that there are 2 bonds. One bond is here, you can see, and another bond is here. So 2 azo bonds are there, and that's why it is called as divalent dye. And reactive violet dye, RB5, here you can see only one bond is there. So it is mono azo dyes. Third component which was taken for experiments, that was acid red 14, acid dye AR14. It's also monotype of mono azo dyes, and then Congo red, it is divalent diazo dyes. Right? This is basically Congo red. So 4 types of the dye. One is acidic, another 2 is reactive, and third one is direct type of the dye, is Congo red. So materials, all these 4 materials were first analyzed, characterized. The different formulas are written, molecular weight is written, percentage carbon, hydrogen, and theoretical percentage carbon is calculated. As per that, purity of the material is checked, and then with respect to spectrophotometer, their lambda max is found out, maximum wavelength is of all the components is determined. Here you can see at the bottom between 400 to 700 it is being one aspect of the little been scanned for observance, and you can see that peaks are there, that is lambda max. So RB5 597, ER 14510, RB5 560 and CR 495, those things are identified. For the color removal, history color removal, those lambda max is important. Now ozonation of dye wastewater. Ozonation of dye solutions were performed in semi-base mode of bubble reactor. Concentration was 1000 to 2000 based on the purity. As far as purity is concerned, that is being found out what material used in the experiments were impure as it is, as per se they are used. So good purity was of AR14, as far as RB5 reactive iodide, its purity was very less. So concentration of 1000 to 2000 milligram per liter that is being taken for the experiments. Ozone was generated in gas phase by passing pure dry oxygen through ozone generator. So ozone was generated, as we know that ozone can be generated by air as well as from oxygen. So here ozone was generated by oxygen, and the gas flow into the reactor was controlled using online mass flow controller, as well as ozomet was used for finding out determining the concentration, ozone concentration applied for the experiments. This is the block diagram of experimental work. Oxygen cylinder, then ozone generator, here ozone is generated, and the mass flow of the mass flow controller was there to measure the to see the flow, to fix the flow of the ozone monitor, as I told you in the previous slide, and that was used to measure the concentration of the ozone applied, and then ozone reactor, and then again ozone monitor was put on outlet. So inlet and outlet on both sides ozone monitors were put, and the difference of the ozone was used for calculation of the ozone consumption. And the reactor used was like this. At the bottom, porous plate was put, ceramic porous plate was put. The capacity no doubt is around 1 liter total, but utilized capacity for 500 ml dye solution, because bottom and upper portions in space was kept for further connection and upper space for inlet and outlet. So the porous ceramic plate was put here just to convert the ozone into the bubble form in order to have proper mass transfer. As we know that more mass transfer will be there, if we generate bubble the ozone gas inside the reactor. So the bubble size was almost less than 1 mm. It was like that, or ceramic plate was put. So small size bubbles were formed, so to have a good transfer, mass transfer of the ozone. Reactor was filled with 500 ml HO dye solution, for to pH 7. So as we know that it was previously found that during the ozonation, huge reduction in the pH was there from around 7.5 or 8 goes to reduce up to 2.5 pH during the ozonation because of the formation of the some acids. So as a byproduct of them. So in order to keep the pH around 7, buffering was done. Influent gases ozone concentration was maintained at 58 to 58.5, around 58 ozone concentration milligram per liter was maintained, and 20 ml samples were taken, collected at different intervals from 20, 30, 40, 50, 60, 80, and up to 90. Later on, 90 minutes were not taken into consideration, to 80 minutes only. So original dye solutions as well as collected ozonated samples were analyzed for pH, color, electrical conductivity, BOD, COD, and TOC. So this analysis was done just to know the behavior of the or how the ozone consumption takes place. As I told you that variation of the concentration was from 1000 to 2000. RB reactive dyes concentration was somewhat more, 22,000 milligram per liter, compared to the two other dyes who were somewhat more clearly 1000 milligram per liter. The flow rate was adjusted 0.5 plus minus 0.04 to have ozone concentration around 58 plus minus 0.5 grams per liter. After 60 minutes of the ozonation, the sharp reduction in ozone consumption is found. Initially, we can see in the wall graphs, initially almost near to 100 consumption. Whatever the ozone is coming is consumed by the dye solution. But after what, it goes reducing as byproduct forms, color is removed, and then after around 60 minutes and further, it was found that it becomes somewhat stable. Further, no reduction is almost, no consumption is almost found. Whatever is coming, more than 90% of them are going to come out, and that's why it is almost stabilized. So now color reduction, how the color is reduced, you can see it. Before I have shown you the slide of finding out lambda max. Similarly, using a spectrophotometer on lambda max, you can see how the reduction of the peak is there. So this is 300 to 700 nm region in which it is being scanned for turbines. So it was found that this is 0 gram. Top one is original dye solution, 0 gram O3 per gram of TOC. Actually, data are normalized with the TOC because of variation in the concentration on the different type of the dyes. It was decided that it's better to have normalized the absorbance. So it is normalized to TOC. As for that, you can see that initial peak is there, then after it is going to be reduced, and like that, after almost 80 minutes, almost no peak is there, you can see, which is in case of RB5 as well as in case of reactive violet light. So reactive black as well as reactive white. In both the cases, you can see that how the peak is going to be disappeared. This is color reduction in terms of the platinum cobalt scale as well as pictorial view. On the right side, you can see the pictorial view of the samples collected after the different resolution time. First one, this first one, you can see the original dye, and then second one, third one, fourth one is 20, 40, 60 and 80 minutes. So like this, you can see that almost in the last 80 minutes, no color is there except in AR14 slide around 10 minutes is there. Otherwise, even you can say RB5 reactive violet, after 40 minutes or 60 minutes itself, there is almost no color. You see CR is present. And this is platinum cobalt scale starting from the first 20 minutes, because initially the color cannot be compared with the platinum cobalt scale. So high concentration of dye was there. This is what is the effects of the ozonation on physical and chemical parameters. So other parameters as far as dye concentration is concerned, so you can see that it is pseudo first order reaction is there, continuously reducing the concentration of dye, and second graph is indicating the conductivity. Conductivity increases with the ozonation as we go proceed further time of ozonation. Conductivity increases, and that is because of the formation of the acids. And reduction in COD and TOC was found around 55% and 73%. You can see that reduction of COD as well as TOC It's compared, that is compared to the TOC to TOC0. TOC0 means initial TOC. COD to COD0 means initial COD. So around this much of reduction in COD and TOC is found. Reduction in COD to TOC ratio indicates partial mineralization. Here you can say that in this graph, COD to TOC ratio is going to be around 3. From that, it's going to reduce down to 1.67. So this implies, what does it mean? COD TOC ratio is increasing. It means partial mineralization is there, complete mineralization is taking place. So, and last one is showing the BOD to COD ratio, which is also a very important parameter as far as biodegradability is concerned. Increase in BOD and COD ratio, right, from almost 0 to around 0.5. This indicates that improvement in the biodegradability of dye is there. So further treatment, biological treatment can be moved. As far as this PES graph is concerned, almost it remains stable because of the application. So this was the case in case of the first element, first dye, that is reactive black 5. Similarly, in case of the reactive violet 5 also, around 80% and 73% COD and TOC removal was found. And COD TOC ratio again lowers down, becomes around 2, which means partial mineralization is there, and BOD reduction is there. This particular dye, in this case, you can see that BOD is initially rising and then it is going to be come down, because initially due to the formation of some other aliphatic compounds it rises, and then ozone itself reduces some until that convert into CO2, some carbonaceous compound, and that's why some reduction is there. BOD COD ratio, you can see that again going to rise up to 0.5. In AR14 acid red 14 compound, basically reduction is 80% and 60% as far as COD TOC is concerned, and biodegradability improvement is there. Its concentration, its purity was not more, and that is why still, as far as numerical value is concerned, after ozonation, more than 250 mg per liter of COD was still remaining in that. We will see later on further treatment of aerobic biodegradation. This is in case of the CR Congo red dye, the red dye, in which 84% COD and 70% TOC reduction was found, and biodegradability improves around 0.5, more than 0.5. Now, ozonation byproduct. As far as I told you that ozonation gives, first it breaks the double bond, azo bond, and due to this reduction in the color is there. And then after, aromatic rings are broken, and in that complex compounds convert into the aliphatic simple compounds, and this causes conversion of the carbonaceous material from one to another. So this continuous ozonation was the formation of formic and oxalic acids, various aldehydes also, and it lasts, finally it forms oxalate or formate as far as carbon is concerned. Right? So final product will be like that, maybe formation of formate, oxalate. Conversion of amine groups in case of some dyes, we can see NH2 group was attached, sulfonic group was attached, SO3H, that is sulfonic group. In some compounds it was attached, that is NH2 group, amine group. So these groups are, due to the oxidation by ozonation, they convert finally into nitrate. And finally, sulfuric group will convert from acid to sulfate. So these conversion as a almost as a part of end product. But before that, as I told you, some acids and aldehydes ketones are formed. Because these are the end products. So for that end product study is being done by and chromatography that I will show you later. In that sulfate concentration, how it increases, oxalate, formate, and nitrate that was determined using and chromatography. But for intermediate byproduct, it is GCMS analysis was done. So GCMS analysis for ozonatic dye solution was carried out for identifying ozonation byproducts. So as we know that dye samples were in water, so directly those samples cannot be applied in GCMS. So to have checking of sampling sample for different intermediate byproducts in GCMS, first we require to derivatize the samples. Then procedure is standard procedure as per EPA. I think EPA 6 procedure I have taken at the time. So that procedure was followed for the derivatization of samples using PFBHA, and as it is relatively non-polar and extracted with hedging. So first the sample was derivatized with the PFBHA, and the procedure as per the EPA standard procedure was followed for that. I'm not going to discuss that, but in that some acids were added, temperature was maintained, it was kept for more than 1.5 hours, and then after it was vortex was formed, and then hexene was added in there, and after again forming the vortex, the hexene which is coming on the top of the sample that is being collected as a sample. So such type of process, typical process, standard process was followed for derivatization. As we know that in order to identify the intermediates, we need to derivatize the sample. So hexene extracted samples were collected, and then chromatographs were obtained from GCMS analysis of hexene extracted ozonatic dye solution. The analysis is being done for using GCMS, and in that GCMS analysis column which were used. In that also the standard procedure was followed. I think Colossus 2000 company GCMS was there in Vatican, for which I analyzed all the samples. So, and the column which was used at that time for analysis in the GCMS was DB5 column was there, and the GCMS carrier gas was used helium. So helium gas was used for as a carrier gas, and the samples were analyzed for around 35 or 40 minutes. That I will show you in the program later. And different temperature. In that also the standard procedure was followed. Temperature was raised from the 50 to around 250 degree in steps. So according to that standard procedure, the identification of the several aldehydes and ketones as a ozone byproduct was done. The mass spectra of identified peak was matched with the mass spectra of same compound available in the library of mass spectra. So in the GCMS itself, the instrument was supported with his main library, with standard mass spectra of different compounds was here uploaded by the company itself. So we can check using those main library spectrum the compound which you have found, you are getting as a analysis is matching with which compound. So mass spectra of the same compound was matched with the library mass spectra main library available in the GCMS itself. Information about ozone byproduct that were positively identified was acetaldehyde, acetone, glycoldehydes, dihydroxypropane, benzaldehyde, glycol, methyl glycol. All these things are there. I will show you in coming yes. So here you can see the crystal different chromatograms generated from GCMS analysis. Comparison of the chromatograms of hexene extracted PFBHA derivatized unozonated as well as ozonated RB5 solutions. I have taken one example. This is for reactive like 5 solution. So top one is unozonated one. A simple line is there. You can see no peak is found there. Unozonated sample of distilled water, and then milky water. Then the different doses are there and the time frame, because these pictures are being taken. The complete graph we have broken into the different part up to 11 minutes, then 20 minutes, and later on I think up to 40 minutes. As I told you, that 35 to 40 minute time in duration is there, in which sample travels through the DB5 column and different ozonation byproducts formed can be identified using the different peaks. Here you can see that number of peaks are shown here. We have manipulated those peaks as V1, V2, V3, V4, V5 like that. And some peaks are there. You might be seeing in the slide that U1, U2 like that, some peaks are shown. So basically those peaks were that type of the peaks which I could not identify clearly. Tentatively those I have identified, it could not be identified clearly. So this is the chromatogram of up to 20 minutes, then it is to 40 minutes. Further you can say B6, B7 up to around B11. These compounds are identified as a byproduct during the complete traveling of 40 minutes of sample in DB5. Now you can see here the summary of that. Byproduct codes I have written here: B1, B2, B3, B4, B5, B6, B7, B8 like that. These things are there. So compound name is there, and then which patent compound is identified is acetaldehyde, acetone, glycoldehyde. All these things are there. B1, B2. Here you can see that here B1, B2. Nearby two compounds are there. So these are basically same compounds, but these are as a stereoisomers. You know that stereoisomers, same thing is there, same molecular weight is there, but due to some arrangement of different arrangement, they are identified in the GCMS analysis very near to each other. So they are stereoisomer type of the compounds: acetaldehyde, acetone, and glycoldehyde, benzaldehyde. All these things are being identified as a ozonation byproduct. Other products which are glycols are methyl glycol, and then propanaldehyde, formaldehyde. Well, here I was telling about this U1, U2, and these things are there, in which I have written that tentatively identified, and that is probability of what thing is there. So because we were not sure that which compound will be there, then here you can see these are the points which this is the graph for compound of acetaldehyde. This is the graph for benzaldehyde. The top one, you can see that top one is RB20. It is written. It is automatically came along with the picture which is we can download from the GCMS screen, your computer screen. So here already details are, but the detail of samples are being put, those can be shown here. RB20 is after 20 minutes of ozonation of reactive black dye. That sample was taken. Here you can see that top one is the actual chromatogram and bottom one is of library. So male library, here you can see it is here male library. So male library is matching, I think date is 301, right? 301 is their benzaldehyde. Check it. Yes, as you can see here 301 is benzaldehyde, right? So such peaks can be identified here. This is there, just about, I have shown two just for matching purposes. You can how the library matching has been done. So that is, and you can see this is rest of things, M over Z or whatever they are, AU units, they are basically the CMS units automatically coming mass and depending upon the mass. And this is 181 is basically showing the BHA mass values. In each and every chromatogram, we can see that 181 will be there. Here, end products formed after ozonation. As I explained you earlier also, that basically sulfonic groups after the ozonation converted in the end into the sulfate. Amino groups finally converted to the nitrate, and carboxyl groups, whatever the carbohydrate material is there, that may be oxalate and formate, oxalate and formate. But here you can see the concentration is very less of them. Sulfate and nitrate concentration is continuously increasing, almost going towards saturation later on after 18 minutes of the ozonation. Here you can see. Right? So here on the right side, BFA, volatile fatty acids, and formate is also shown that how it is going to be increased first, and then for further ozonation it may reduce also. So BFA, whatever the BFA remaining, that may be reduced afterward in aerobic biodiversity also, because it is lighter. Now, after ozonation of the samples for up to 80 minutes, those all samples were analyzed for the aerobic biodegradation. As I told you that ozonation causes to improve the biodegradability of the material, dye wastewater, and we have seen in the experimental results also that BOD COD ratio increases up to around more than 0.5, is 0.5, near to 0.5 BOD COD ratio was there. So further study was done for biodegradability for testing the biodegradation of ozonated sample. So before that also, I'm not showing here that study. I did also the toxicity study using the video track, DOD track. I did the toxicity study for all the samples, and on the basis of that also it was found that toxicity was not there even after 40 minutes. Near around 10 minutes or 15 minutes of ozonation, in some dyes, there was some period where BOD was very less, so we could say that some interference or toxicity may be given. Otherwise, after 40 minutes or near about 40 to 60 minutes, 80 minutes ozonation, there was no any toxicity or effect of toxicity. So the biodegradation of ozonated samples was done for up to 40 days, and here about even around after 10 days we can see that almost COD is going to be stabilized. Here TOC is going to be stabilized, almost becomes constant. No further reduction was there in COD and TOC after around 10 to 12 days. So it is now or finalized stabilized solution. Around, in case of reactive lead 5, around 89% COD removal was there, 87% TOC removal was there observed for 8.3 milligrams CO3 consumed. 8.3 means this. So this is 20, 40, 60. 60 minutes of resolution. So after 60 minutes of resolution, it was found like that. And after we can say the 80 minutes of resolution, we get more than 90%. But it's near to 80-90% density there after 60 minutes of resolution. This is for RB5, reactive violet 5, around more than 80% COD TOC reduction was there, but here for 40 minutes. So as I told you initially also, the reactive violet 5 was somewhat less purity, and that's why the concentration of COD, initial COD was also somewhat less. And here the 40-minute ozonation caused more than 80% of TOC removal, and as far as further reduction is concerned, that is more than 90 to 92% reduction is there after 60 minutes of ozonation. This is the partition showing the block items showing different percentage removal by ozonation, then removal by aeration and remainder. You can see here 10 to 15% remainder is there in case of both type of the dyes. And in case of AR14, acid red 14 dye, more than 80% reduction in COD, 75% TOC removal was observed at 7.7 milligram O3 means 60 milligrams. Here also, after 18 minutes of ozonation, more than 90 or near to 90 to 92% reduction was found. In case of CR, this dye was, as far as results are concerned, we can say that Congo red, that was in that case after 60 minutes, only 60 minutes of ozonation, more than 90% reduction was found in case of COD as well as TOC. I think how much time I have to see, so still we can have some time. So I will now discuss about the separation of dyes from mixed dye solution using SPTLC. So how the process is being done, just study to separate out the different dyes from the mixed dye solution. As we know that in actual textile industry wastewater, different types of the dyes are used, not a single dye, different types of the dyes are used. The wastewater generated is mostly of mixed dye type of nature. So the study was done to separate out the dyes from mixed dyes, and then ozonation of the mixed dyes, and then further aerobic biodegradation of mixed dyes also being done, similar to these 4 compounds which I have explained to you. So for that TLC was performed, thin layer chromatography was performed on 10 by 10 centimeter aluminum bed silica gel. Those who have used this SPTLC, they might be knowing that for development of the sample, for doing the TLC analysis, we required the aluminum bed silica gel plates are there. Over these compounds samples were developed. So aluminum bed silica gel 60 F254 plates standard. These are being brought for Germany. So the instrument was purchased at IIT Kanpur that time, and I was working there. So I was lucky at that time that I could use that instrument also to perform my separation analysis using this. So plates were developed in a saturated glass twin chamber CAMA. Actually, that instrument was from the chemical company. So in a solvent system, phenol, water, 8⁵2 volume by volume. So as to develop the silicon, we require 3 things. One chamber is there, which is called as glass twin tough chamber, and in that chamber, aluminum bagged glass silica gel plates are being put after sampling. I will explain you that how the sampling is being done. So after sampling, that is being put inside the solution, and that is called as solvent. So that solvent is very important. Which solvent is used to develop which type of the material, which type of the compound, that is very much, you have to do a lot of study for that. So I took around 1 month to find out the phenol water 8 raised to 2 solution to have a proper result. Lot of trials we did after searching the literature, and finally phenol water ratio 8 raised to 2, it was found okay that there was proper separation I found. I will show you later on the details of the separation, how it looks like. So that is being done up to the development length of 7 centimeter. Almost 10 by 10 centimeter plate is there, you cannot go beyond 10. So it's up to 7 centimeter development length we used to choose, and that is automatically computerized system is there. Even sampling is being done using the computerized system, automatic sampling is done, and it is being applied on the plate. The samples were applied on the plate also automatically. You have to feed in the computer the interval, amount, everything. It is being distributed, put on the aluminum plate. So chromatograms, and then after, whenever you have developed those samples in that trough chamber using phenol water ratio or any solvent which you found, after that, that plate is again being put into the WinSet instrument, and WinCat software was there. Using that, you can analyze the sample. So chromatographs were evaluated via peak area after scanning in TLC scanner 3. So whatever the plate is developed, aluminum plate is developed using solvent, that plate is being put into the instrument HPTLC, and there TLC scanner 3 is the name of the scanner is there. We required to scan that plate using TLC scanner 3. After scanning that, in the wavelength region of 350 to 600 mm, WinCat software is used for analysis. You can do the analysis similar to the spectrophotometer, in which concentration can be found. So that I will show you now. You can see here, this is the separation of different dyes. Here you can see that it is showing in millimeter height of, that means height of the plate. 10 by 10 plate was there. So this is in millimeter. Go up to 4.5 it goes. So initially around between 20 to 50, here RB5, reactive black 5 was raised, and we put the aluminum plate for the development in the solvent, phenol to the water ratio 8 raised to 2. It is to be put for at least half an hour to 2 hours. Depends, time depends on different things. Yes, phenol is highly volatile material, so it took very less time. Within half an hour it develops. So for it is different for different solvents. So here RB5 is raised up to here, then reactive violet 5, then acid red, and then CR. So this is peaks are found, identified after WinCat's analysis. Here you can see this is the different concentrations were applied after ozonation. So these are the now result of ozonated samples, chromatograms of ozonated samples. TLC was performed on 10 by 10 aluminum bagged silica gel, pre-washed with methanol. So for ozonated mixed type, ozonated pre-washed means everything is to be washed. Plate is to be washed by methanol first, and then it is to be applied, dried, and then sampling is being done. After sampling, it is being put into the solvent, and then after drying it, it is being analyzed into the scanner 3, scanned into the scanner 3, and after scanning it, using WinSet software, you need to analyze. So here different samples were there. Lower one is upper highest peak is showing the highest concentration, and then how the concentration is reducing. You can see that concentration is going to be reducing. So The analysis is being done for that C over C0 concentration, initial concentration C0, and then C concentration, actual concentration. We can see here also the reduction in the um, dyes, different dyes. Here all dyes are different, separated dyes are different. From the mix, this sample applied here is mixed dye sample, and for mixed dye sample, 250, here it is written, 250 milligram per liter of each dye solution was mixed. So here, that we can see that all four dyes are separated. Here you can see that reduction is, this is for individual, this is for mixed. Right? So on the basis of this, then mixed dyes is being found out. So here you can see the individual dye solution is within 6 minutes, almost no color is there, because concentration taken was very less. Here you can see 250 milligram per liter each of our mixed. So individually first, as far as analysis is concerned, individual dyes were analyzed first, and then mixed sample was taken. So 250 milligram per liter strength was not less. So it was depolarized within 6 to 7 minutes only. So this is the COD, TOC, BOD, CD ratio, and platinum to water scale color. Similar to the previous study, here you can see that it is being completely depolarized after 18 minutes of ozonation for complete mixed dye. Right? Then similar study has been done about COD and TOC of effect of ozonation as well as physical and chemical parameters of mixed dyes. Means here how the ozone is absorbed, then color removal, then conductivity increases, and then after biodegradability improvement. And similar to the individual compounds studied, mixed dye compounds were also studied, as this type of graph for individual compounds also I have shown before, that about 91% COD removal, 90% TOC removal was observed for 11.1 milligram per milligram ozone consumed per milligram of initial TOC. Here also in all the cases, in all the graph, I have shown the normalized y-axis. Normalized values I have shown. Normalized values means the dose which we have applied is normalized with the TOC, initial TOC. So 60 minutes of ozonation, here you can see that 11.14 is basically, third one is for 60 minutes. So after 60 minutes of ozonation, also around 60, more than 90% removal was there. So total 83% COD removal, 80% TOC removal was observed for this month, is after 40 minutes also. But I think in this study it is not there, but one more thing was found in this study, that in case of mixed dye solution, whenever ozonation was done, so I think here you can see here you can see, yeah. So rate of decolorization of dyes, reactive dyes were found. Reactive dyes were found. Rate of degradation of reactive dyes was more compared to the acid red and CF. It was one of the conclusions which were found. In detail, I have not shown you, but here from the graph, you can see from this graph itself. The lower one is, this is RB5, reactive violet 5, and before this, this black one is also of RB5, and this dot one is top, these two. This is AR14 and CR. So rate of degradation of reactive dyes was more compared to the acid red dyes and Congo red dye, direct dyes, in case of the ozonation of mixed dye. Whenever we do the ozonation of mixed dye, so all dyes are not having the same rate. As far as individual dye is concerned, with one compound only, so we are having the rate of degradation of that. But here in this case, rate of degradation of reactive dyes is faster, more compared to the acid rate and other dyes. That was one of the conclusion of that study also. Now, here, finally, we can say that ozonation is highly effective for decolorization of acid, reactive and direct dyes. As I took for the study these three compounds, acid, red, reactive dyes, two compounds and direct. So ozonation is highly effective for that because even after 40 minutes, almost 40 minutes of the ozonation, there was complete decolorization. We may see, we have already seen in the picture also, photograph taken on the display tubes, circles within them. It is completely decolorized after 40 minutes of ozonation. Ozonation improves the biodegradability of synthetic dye, and almost in all the four compounds we have seen, as well as in the mixed dye also, that biodegradability after the ozonation of the 60 minutes is around 0.5 BOD-COD ratio. So biodegradability of all the compounds improves, and that could, because of that reason only, the integrative treatment with ozonation followed by aerobic biodegradation seems viable option because of that, and we did that study also, as I have shown you that after ozonated samples were aerated for 40 days until they stabilized. They were stabilized even after around 10 to 15 days, they were stabilized. But the reactor was run, all the reactors, aerobic reactors were run for around 40 days. It was found that most stability was there, no further reduction was found. So, integrated treatment may be one option of removal of organic contents from the dye waste water. No doubt, the concentration, if we took the low concentration, suppose around 100 to 100 or milligram per liter, so as far as ozonation dose is concerned, because I took the ozonation dose which was quite high, around concentration was 58 milligram per liter. So that concentration was quite high. In that case, reduction may be around, I think, not more than 30 milligram. So what only problem is what in case of the ozonation, as we discussed earlier, that it requires online on-field generation, and somewhat costly if you install the ozonator, because we require the oxygen also. Quality of the ozonator is good as far as oxygen is concerned compared to the air. No doubt, in wastewater treatment purposes, several places, several industries also, they are using air ozone generator, from air generator. This is what is about from my side. So if anyone is having any question, inquiry, you can raise through the message you can put here in chat, or directly also you can ask. So anyone is having any query can ask.
The participant can use the chat also for asking the questions. You can directly ask.
Sir, one question is there. Hello.
Yes.
Yes.
Sir, what is the cost of treatment of this ozone as compared to the other treatment methods?
It is really very high compared to the other treatment processes, as several times during the presentation also, I told that its use is not so at a so large level, and that's why the generator cost is high as well as power consumption is there. No doubt the generator which I used, and nowadays in India we are having the manufacturing of the ozone generator. There is no any such problem. No doubt the generator as well as the different monitors as well as flow meter which I have used there in IIT Kanpur, they were from foreign, but nowadays even in our country also all those things are available. So the generator as far as India make is concerned, it's not more than it is around 10 to 12,000 cost of the ozone generator. So, and maybe of different company, different cost may be there. That is one thing. Another thing is power, continuously power it requires. So that thing, and a third thing is if you are generating from oxygen, so that is going to create a cost. So as application use is not so at high level, so that way cost is low. Otherwise, in if you consider the benefits also, lot of other benefits are there. Quickly you are going to remove the carbon. Though no generation of the sludge is there, so these things are advantages.
போடலாம் கடைசியில் பார்த்துக்கலாம்
Yes.
லெட்டர் அனுப்பலாம் நான் அனுப்பல நான் ரெடி பண்ணுறேன் பின்னாடி பார்த்துக்கிறேன் ஓ ரைட் ரெடி லெட்டர் வேணுமா லெட்டர் அந்த பாடியில் இருக்குது அட்டாச் பண்ண மாட்டேன் அப்படியே போஸ்ட் பண்ணுறேன்
Kangaras.
படிக்க மாட்டாங்க
Kangaras. Want to ask anything? Your mic is on.
So I have one question, sir.
Yes, please go ahead.
So I have one question. So can I have one doubt, sir.
Yes, you can ask.
We can use this technology to all kind of wastewater.
Yeah. This technology can be used for other wastewater also, and several you can see in the literature also. I have not included literature here, but in literature you can find that ozonation is being used right from the different type of the wastewater up to ternary wastewater also.
Okay.
Which is highly calcinated. So it is not so, it can be used for any type of the wastewater. Results are somewhat maybe plus minus, whatever. In literature you can find every field, every wastewater. For every wastewater, ozone is used.
Okay, sir. I have another question, sir. I have another question. So nowadays we have many researchers use membrane technology.
Yeah.
Membrane technology. Okay. So many people shift membrane technology to purify waste treatment.
Yeah.
What is your opinion? Okay, opinion about the ozonation treatment and membrane filter treatment.
Yeah. So good questions. Actually, the same problem is there with membrane technology also. As in case of ozone, cost is very governing criteria. Cost is high. Even compared to the ozonation, you may find that for treating the concentrated wastewater, membrane technology may be more costly compared to this. For I am telling for concentrated wastewater, because repeatedly membrane is liable to be clogged, may be replaced. So that thing, no doubt, if recovery can be done, it may counterbalance, but still it is in research area. It is not 100%. People are not 100% sure that recovery is making some benefits to counterbalance the initial cost or operation cost of the membrane technology.
Okay, sir. Okay. So maybe we can combine both technologies, sir. We can combine both ozonation and membrane technology.
Yeah, of course. As I told you in the last, that integrated or combined treatment in nowadays is mostly a matter of research because of this reason. Because some methods are having some advantages, some are having some disadvantages. So how to integrate or how to combine such methods so that overall minimum cost, overall minimum disadvantages may be there. So minimum generation of the sludge or minimum power consumption, all these from that point of view people are doing now research. So integrated or combined technology is really have a good future. No doubt a lot of work has already been done, but they can be combined. As I explained that ozonation then combined with the aerobic treatment. Similarly, in order to reduce the load after ozonation, membrane technology can be used.
Okay, thank you for giving answers, sir. Thank you.
Okay.
Okay, if no questions are there, then I am very much thankful to Professor UK Khare. He has delivered a very good lecture on chemical oxidation technique, that is ozonation. So I think we'll be finishing our session here, and we will be meeting.
One question is there.
One question is you can.
So I am going to comment over that. Someone has asked that Suchitra. It is quick process as shown by data and presentation. Still, it has not gained popularity. Please comment. So, as we discussed with the other participant also, cost is the matter, and no doubt it's a quick process. In India, as far as in India, cost is governing factor in all fields. So because of the high cost, it is not gaining the popularity. Until or unless, as we know that initially mobiles were very costly, but nowadays they are low cost mobiles are available. So utilization is also less because of high cost. Until or unless its application is increasing, not increasing, it is very difficult to come down with the cost. So the cost is the basic criteria, basic.
Okay, thank you, sir. So we will be meeting tomorrow at 10:30 a.m. for the fourth day sessions. Thank you.
Okay. Hello, participants. Hello. Am I audible, sir?
Yes, you are audible. Yes.
Sir, tomorrow's schedule is slightly changed. The afternoon session will be taken in the early in the morning, and morning session will be taken in the afternoon.
Yes. I forgot to tell that the second session will be the first session, and first session will be the second session. That is the change for tomorrow. Okay, thank you, Professor Ankit Patel.